In the given question, it is a closed traverse conducted for the AB, BC, CD and DA. For each line, the given data, the lengths and bearings have been collected from the survey. But one of the reading DA has been not recorded, we have to find it. In the previous class, we have discussed that for any survey line, if this is north, this could be east, west and south. The projection of the survey line to the east-west is called departure. And the projection of this line to the north-south line is called latitude. And if you know the bearing of this line as theta, then and length of survey line as L, and departure is L sine theta, and latitude as L cosine theta. In any closed traverse, the summation of total latitudes of all survey lines and the summation of departures of all survey lines shall be 0. We shall use this condition and find out the length and bearing of the survey line. I repeat, in any closed traverse, the summation of latitudes and the summation of departure shall be equals to 0. We got two conditions and we got two unknowns we can find out. Okay. So first we'll prepare a tabular form calculating the latitudes and departures, and thereby we'll use these two conditions in order to calculate the unknown values. Right. So line, length, bearing. Remember, these bearings are given in whole circle bearing. Whole circle bearing. When the given values are given in whole circle bearing system, we have denoted that this theta angle here is always taken either from north or south. Here also theta is either north or south. So, but these all values are taken with reference to north. So, we have to convert these whole circle bearings to reduced bearings, where reduced bearings are denoted with reference to either north or south. So, we'll write down here whole circle bearing. We'll copy down everything here. Now we'll convert these bearings to reduced bearings. When you calculate the reduced bearings, now you are supposed to calculate the latitudes of survey lines. Latitudes is given by L cos theta, and departures of these lines L sin theta. Now finish the tabular form. I got here 4 lines AB, BC, CD and DA. The length of AB is 75.50, length of BC is 180.50. You mentioned the units here. 60.25 is the length of CD, and DA length L, let us say it as L. And bearings, whole circle bearings are given as 30 degrees 24 minutes. This is 110 degrees 36 minutes. This is 210 degrees 30 minutes. And let us say the bearing in reduced system as theta. We need to find out this theta and L values. So as because 30 degrees 24 minutes, if you want to convert to full circle bearings to reduced bearings, recall what we have discussed in compass summary, right? So whole circle bearings are always represented with reference to north. So the first line comes 30 degrees 24 minutes. So this is north, 30 degrees 24 minutes east. It is northeast. Next is 110 degrees 36 minutes. So it comes here. This is 110 degrees 30 minutes. But we all reduced bearings should be always be with reference to either north or south. So what is this angle? From 180, you have to deduct this 110 degrees 36 minutes. And if you do so, you will get south 69 degrees 24 minutes towards east. Next angle is 210 degrees 30 minutes. 210 degrees comes in this quadrant. It is southwest quadrant. Southwest quadrant. Now you need to calculate this angle. So you know the total angle. From this total angle, 210 degrees 30 minutes. If you deduct 180 degrees, you will get 30 degrees 30 minutes. So what I did, I have examined the given bearings. I found out these are in whole circle bearing system. First I need to convert to reduced bearing system, that is with reference to north and south. In whole circle bearing system, all these angles are represented with reference to north only. Right? In order to calculate latitudes or departures, this theta and this should always be either reference to north or south. So I have converted whole circle bearing system to reduced bearing systems. Now all that you need to do is you need to calculate the latitudes of so-called lines. So 75.50 multiplied by cos 30 degrees 24 minutes will give you a value of 65.119, and 75.50 multiplied by sin 30 degrees 24 minutes will give you as 38.206, and so called all these values 63.507, this is 168.958, this value has 51.913, this has 30.579. Now this will be L cos theta, let it be in that way only, and this could be L sin theta. Right? Now I have said in the previous class that when you are writing down the latitudes and departures, this is north, this is east, this is west, and this is south, and this is normally departure line, departure. This is latitude and this is latitude. I have said that in northeast quadrant both latitude and departure are positive. In northwest quadrant departure is negative and this is positive. Just like you have the coordinate geometry xy, the same way it will be here also. Here is minus and minus, and here departure is positive and altitude is negative. Okay, these three are for practice, right? So you note down these three in the left hand side roughly and use those things in order to put here. Now look at the quadrant and assign the signs of latitudes and departure. Northeast. In northeast, both the latitude, The first one is departure, second is latitude. The first one is departure, next one is latitude. So both of them are positive. The second is southeast quadrant. Southeast quadrant, departure is positive and latitude is negative. Next is southwest quadrant. Southwest quadrant, both are negative. Both are negative. We doesn't know the quadrants where your bearing of DA lies. We shall find it out. Okay. Now, southeast quadrant of now, as I said, in a closed traverse, summation of amplitudes is equals to 0. Right? Now, 65.119 plus 63.507 minus 51.913 plus L cos theta equals to 0. Similarly, summation of departures equals to 0. I have left some space in order to do the calculations part. 38.206 minus 168.958 minus 30.579 plus L sin theta equals to 0. Simplifying this, you will get, madam, L cos theta equals to, so I have made a small mistake here. I have taken southing as positive. Southing is always negative, easting is always positive, right? And northing is also always positive. West is again negative. South, west is always negative. Remember this. South and west is always negative. North and east is always. So if you can simplify this, you will get this value as 50.3011 and this as minus 176.584. Now sign represents departure. So when departure is negative, it represents west. So and when cosine, that is latitude, is positive, when latitude is positive, it represents north. So your DA bearing lies in the quadrant northwest. Right? Now you got two equations, 1 and 2. If you simplify these two equations, you will get this d theta. Simplifying equation 1 and 2. So L sin theta divided by L cos theta, that equals to, you should not take the negative values here, you have to take the positive values only. Right? By 4 divided by L cos theta, that is why I have taken modulus. 1 1. So modulus of this value will give you as 3.5105 and L get cancelled. This is tan theta. Then theta is equals to tan inverse of 3.5105. This will give you an angle of 74 degrees, 6 minutes and 0 seconds. So this not the bearing of this is given by 74 degrees, 6 minutes towards west. Now, how will you get the L value? So L value is given by summation of L square plus summation of D square. You do under root, then you will get L value. So simplifying equation 1 into the same way. So L cos theta square plus L sin square theta whole square whole under root. Okay. So L cos theta of this value is given by 50.301 whole square plus L sin theta is given by minus 176.584 whole square. And if you calculate this value, you will get as L equals to 183.608 meters. So L value is given by 183.608 meters. So finally, we have to write the length of line DA equals to 183.61 meters and magnetic bearing is not 74 degrees 6 minutes. So in this case, you calculated the length and bearing of the same line. In the next problem, you will calculate the lengths of two lines where bearings are given. In the next problem, we will calculate the bearings of two different lines. We have three cases. One is this, the length and bearing are missing of one line. In the second type of problem, the lengths are missing for two different lines. The third problem, the bearings are missing for two lines. In the previous problem, we have discussed how to calculate the length and bearing of same line. In this problem, we are going to discuss about the same omitted measurement where length of one line and bearing of another line is missing. Now the given data or the missing data is line length in meters and bearing is given to you. The lines are AB, BC, CD and DA. The lengths are 100, 80.5, 60.0 and this is question mark. And the bearings, AB bearing is missing 140 degrees 30 minutes. This is 220 degrees 30 minutes. And this is 310 degrees 15 minutes. Now, you can observe that the given bearings are in whole circle bearing and you can also observe that the DA length is missing, AB bearing is there. is missing. In the previous case, the length and bearing of same line is missing. Now we'll assume this length as L, this bearing as dash. Now, and because this is whole circle bearings, we'll calculate the bearings in reduced bearing system. Now let us say this has theta, and if you happen to calculate 140 degrees 30 minutes, then it will come in southeast quadrant. Southeast quadrant of 39 degrees 30 minutes east, and this in south 40 degrees 30 minutes west, and this in north 49 degrees 45 minutes west. Now if you happen to calculate this bearings, then you are supposed to calculate the latitude and departure. Now latitude is given by L. Now we need to say which one is L, right? So we'll take another pen. So this is L. This is L. So this is theta is given to you, right? So this is L cos theta, and this is L sin theta. So here 100 we know 100, and as because theta is there, we will substitute theta similar to that, and this will be 100 sin theta. And the length of this line is 80.5. 80.5 into cos 39 degrees 30 minutes, you will get as 62.12, and sine will give you 51.20, and similarly this has 45.62, this has 38.97, this has, now what do we calculate this? L cos 45 degrees 45 minutes. L cos theta is 49 degrees 45 minutes. This will give you a value of 0.646 L, and this has 0.763 L. Now let me put the table form to it. Now this is latitude and departure table form. Fine. Now we have to put positives and negatives. I said northing and easting as positive, northing and easting. So north positive. So latitude is always north and south. Departure is east and west. So this is south negative. This is south negative. It doesn't know the theta, so don't put any sign to it. Now we got here east and west. East is positive, west is negative, and negative. Right? Now after you have got this, now I have said in a closed traverse, that in a closed traverse, summation of latitudes equals to 0, which means, right, you have to sum it up and equals to 0. So 100 cos theta minus 62.12 minus 45.62 plus 0.646 L equals to 0. Now if we simplify this, 100 cos theta equals to 107.74 minus 0.646 L. Let me say this as equation number 1. Now similarly, summation of departures equals to 0. That implies 100 sin theta equals to 51.20 minus 38.97 minus 0.763 L equals to 0. Now if you simplify this will become 100 sin theta equals to 0.763 L minus 12.23. Let me set this as equation 2. Now we have to eliminate cos and sines. So how we can eliminate is we'll square and add equations 1 and 2 on both sides. So in order to eliminate this, squaring and adding equation 1 and equation 2, we get, right? So this is 100 cos theta square plus 100 sin theta square equals to 107.74 minus 0.646 L whole square plus 0.763 L minus 12.23 whole square. Now, so this will become cos square theta plus sin square theta. It will become 1. This is 2 times 100 square. So I can put 100 square. I can take 2 here, right? So I can take 2, evaluate this, then multiply with 2. Then you will get this value as 11757.5 minus 157.86 L. That's L square. Now you got a quadratic equation for the simplification. 157.86 L plus 1757.5 equals to 0. Now if you happen to calculate the roots for this quadratic equation, right, by simplifying it, you will get length of DA line as 2 values. That is, one is 1 plus 145.8 meters or 12.04 meters. Either it can be this value or this value. It can be either of those, right? And if you happen to have in a given question, if you have negative value, just discard it, don't consider it. Now what we do is we need to calculate theta value. In order to calculate theta value, we need to substitute this L value in equation number 1, and we need to calculate the cos sin. We have divided by, have to calculate tan theta, then we can easily get theta value. So now how do we do is, as because we got 2 value, we will consider 145.8. We will substitute in equation 1 and 2, and we will get theta value. And we will substitute 12.4 in equation 1 and 2, and we will get theta value. So first we will take when length L equals to 145.8 meters. So substituting L equals to 145.8 meters in equation 1, you will get as cos theta equals to 0.1355, and similarly substituting L equals to 140.8 in equation 2, you will get sin theta as 0.9901. Now when these two values are positive, when departure is positive and when latitude is positive, it says, write down here, since both departure and latitude are positive, the line AB lies in which quadrant? Both positive number, north east quadrant. So how to calculate the theta value? So we have to divide sin theta by cos theta equals to, you will get this value as 7.3070, that is theta is given by 82 degrees 12 minutes. So which means, therefore, bearing of AB equals to naught 82 degrees 12 minutes east. This is when length L equals to 145.8 meters. Similarly, when length L equals to 12.04 meters, right? Same steps you need to follow. Substitute L equals to 12.04 meters in equation 1. It will reduce to cos theta equals to 0.996. Similarly, substituting L equals to same in equation number 2, you will get sin value as minus 0.0304. Now you can see that departure is negative. What? Departure is negative and latitude is positive. When departure is negative and when latitude is positive, it lies in northwest quadrant. So write down here, since departure is negative and latitude is positive, the line AB lies in northwest quadrant. So therefore, tan theta, that is sin theta by cos theta, equals to 0.0304. Therefore, from here we can calculate theta as 1 degree 44 minutes. So bearing of AB equals to 1 degree not 1 degree 44 minutes west. So some of you might be thinking, sir, why we need to calculate theta, tan theta? Why can't we get theta values directly from cos or sin? You shouldn't do that because your line is oriented in both axes. So it is oriented both sine and cosine. So you always need to take the tangent of the line. So you should not calculate theta either from cos or either from sine. So this is how you need to do when length of one line and bearing of another line is missing. In the next problem, we will discuss about lengths of two lines are missing. We will now discuss about problem where lengths of two lines are missing. For example, I am not dictating the entire question. So there are 5 survey lines, CD, DE and EA. This is the line and the lengths are 100.5. You need to find out. This is 75. This is 50.5. You need to find out this. And the bearings are given as north 30 degrees 30 minutes east, south 45 degrees 0 minutes east, south 40 degrees 30 minutes west, south 60 degrees 0 minutes west, and north 40 degrees 15 minutes west. So in the given problem, you can see that the bearings are directly given in registered bearing system. So all that you need to do is directly calculate the latitudes and departures of corresponding lines. Okay. So prepare in tabular form. So let us, this is L and this is latitude, L cos theta. This is departure, L sin theta. Right? Now let me say this unknown BC value as L1. Let me say this unknown value EA value as L2. Right. So 100.5 into cos 30 degrees 30 minutes is 86.59. L1 into cos 45 degrees is 1 by root 2, that is 0.707 L1. This will become 57.03. This is 25.25. This is 0.763 times L2. Similarly, departures of these lines are 51. This is 0.707 L1. This is 48.71. This is 43.73. This is 0.646 L2. So we need to assign the signs now. Signs, I said north and south here, east and west here. North is positive, south is negative. North positive, south negative, 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 positive. Now east as positive, west as negative. East positive, positive, negative, negative, and right. Now we apply the principle, that is, in a closed traverse, summation of latitudes equals to 0, right? That is, you will get as plus 86.59 minus 0.707 L1 minus 57.03 minus 25.25 plus 0.763 L2 equals to 0. By simplifying this, you will get as 0.763 L2 minus 0.707 L1 as minus 4.31. Let me say this as equation number 1. Now, second, we know that summation of departures equals to 0. That implies 51 plus 0.707 L1 minus 48.71 minus 43.73 minus 0.646 L2 equals to 0. By simplifying this, you will get as minus 0.646 L2 plus 0.707 L1 equals to 41.33. Let me say. Now you got two equations, two unknowns. So solving equations 1 and 2. Solving equations 1 and 2, you will get L1, that is, what is L1? Length of BC as 348.58 meters. L2 that equals to length of EA equals to 317.35 meters. In next problem, we will discuss about when two bearings of different lines are missing. Then becomes that the problem is a bit lengthy because solution involves a little bit of application of trigonometrical principles. So, two thetas we have to calculate. That we will do in next class.